Hai, Assalamualaikum warahmatullahi wabarakatuh. Good evening everyone. My name is Amirul Kamal bin Sohaili Kamal, B0717103883. Today, I'll be presenting for BMMU3764, the Bachelor Degree Project 1. This is for the Bachelor Degree Project 1 for the UTEM in Bachelor of Mechanical Engineering Technology, Automotive Technology with Honours from Faculty of Mechanical and Manufacturing Engineering Technology. The title of the project is Design and Fabricate Low-Cost Mini Electrical Vehicle. Abstract. Electrical vehicles are regarded as a key element of future low carbon transportation. This project is focused on designing and fabricating a simple mini electrical vehicle which can be DIY without much difficulties. The design is mostly inspired by go-kart, golf cart and conventional scooter, as the design of these are quite simple. The main components that make it an EV are the motor, the speed controller, the battery, and some switches. Chapter 1: Introduction. The background. Hans Christian Ørsted and Andre Marie Ampere discovered electromagnetism, the unity of electromagnetic phenomena, from 1819 to 1820. Michael Faraday invented the electric motor in 1821, and George Ohm conducted a mathematical analysis of the circuit in 1827. The main method of powering cars from the past 100 years was dominated by internal combustion engine car. But electrical energy still dominates other types of vehicles, such as train and various small vehicles. From the picture, we can see Edison and a 1914 Detroit Electric Model 47, courtesy of the National Museum of American History. EV nowadays. In the 21st century, EV have undergone a renaissance due to the technological development and increasing attention to renewable energy from a variety of sources, including fossil fuels, nuclear energy, and renewable energy sources such as tidal, solar, hydro, and wind energy, and any other combination of them. The electricity can then be stored on the vehicle via a battery, flywheel, or a supercapacitor. By the way, this is the Tesla Model S. It can go from 0 to 60 miles per hour under 3 seconds. A modern EV is very expensive. The infrastructures and R&D causes the price of the EV to be sky high. And also, making a DIY simple mini EV could be difficult to some people, as they may not have knowledge, facilities, and materials needed to make one. And also, when CAD programs needed to be purchased, and also needed a more powerful computer to run it smoothly. Otherwise, you have to wait maybe a day or two to finish computing. The objective of this project is to understand how EV works, to design a low-cost mini EV, and to fabricate the low-cost mini EV that could support an average adult. The work scope and limitation. The design should use minimal and inexpensive part for the low-cost design. It should also have the strength to support the mass of an average adult. The design should be simple enough as for it to not take too much time fabricating, and the limitation of working and traveling under CMCO. With the planning and preparation made for this project, the expected result is finished and working low-cost mini EV. Chapter 2. Literature Review. Introduction. A brief review of literature is provided on the following topics: the introductions to the EV, design principles of EV, and components of EVs, and some of the charging scheme. EV or electrical vehicle is a combination of automotive, electrical, electronics, and chemical engineering by Chan 1993. The overall efficiency of the EVs can be improved by combining several technologies by Chan 2002. Three major systems in an EV, which is the energy source, power converter, and electrical motor. As electrical energy may be produced from renewable energy sources such as wind, hydroelectric, solar, biogas power plant by Kane 2003. Design Principle of an EV by Sharma Panwar and Tripathi 2020. Determining all the technical specification and estimation of load requirements for EV. Also, identifying the environment and market trend for EV. Depends on the market, what type of vehicle that is needed and which one is more popular. Defining the energy supply for different cases such as generation or storage, single or hybrid power supply. Defining the system requirements according to its configuration for various applications such as hybrid EV, which consists of internal combustion and an electrical motor, a battery EV, which mainly uses battery to power up the vehicle, and a fuel cell EV, which usually uses chemical energy such as hydrogen to power up the electricity and move the car. Identifying the primary essentials component of EV propulsion system consists of a single or multiple motor, converter, transmission type, and mounting method. This is the Ford F-150 Lightning, an EV pickup from motortrend.com 2021. As you can see, even though the vehicle is very bulky, it is an electric vehicle. The usual position of the engine in front of the boot is now an empty space. You can store much needed spaces. This proves that electric vehicle can save spaces inside the cabin. EV's key component by Diamond 2009. This is the figure of the key components of an EV, which can be seen from battery charger. It can be charged the battery, and from the motor can go through the inverter to charge the battery, and vice versa. The battery can go to the inverter and move the motor. The battery uses the DC-DC converter to a vehicle, computer, and electronics. Ta-da! Motor. Classification of motors by Ala Vijay and Akhbari 2011. This is the chart of a motor type. For the first one, the induction motor, they have squirrel cage and wound rotor. For the synchronous motor, they have a wound rotor, PM rotor, and reluctance. PM is permanent magnet rotor. And for the PM rotor, they have a surface mounted which the magnet is mounted on the surface and the interior mounted on the interior. There are also permanent magnet, brushless motor, and switch reluctance motor. Power electronic driver. It is a power switching device with its control and switching strategies make our system efficient. The table below shows the comparison of devices by Chan 1999. For a IGBT, it is an insulated gate bipolar transistors. And MOSFET is a metal oxide semiconductor field effect transistors. As you can see from the figure, the voltage drop for the IGBT is medium, is low on transistor, and high on MOSFET. The control power is low on IGBT, high on transistor, and low on MOSFET. The control mode is voltage, current, and voltage. Uses current to control the power of the transistor. And the switch speed. For the IGBT, the switch speed is very fast. The transistor is medium, whereas the MOSFET is very fast. Voltage rating. For the IGBT, it is a medium rating. Transistor is also medium and low on MOSFET. However, the cost, IGBT is low, transistor is low, and MOSFET is high. Primary battery. It is a battery composed of various combinations of anode and cathode. Comparison of primary batteries by Jia, 2015. Some of the primary batteries is the zinc carbon and alkaline manganese, zinc air, silver oxide, lithium sulfur dioxide, lithium thionyl chloride, lithium manganese dioxide, and lithium carbon monofluoride. A rechargeable battery, XN energy sources and energy sources system. That is the secondary battery. The creation of the lead acid battery in 1858 by Plant, Brosley and Pistoia, 2007, Wendt and Tracer, 2013. Later, the nickel-ion alkaline battery was introduced as a power source for the electric automobile by Edison in 1908. Shen, 2016, Thomas, 2010, Zosky, 2006. These are some other critical commercial batteries that are also discussed in detail and summarized in the table below by Jia, 2015. The second batteries is lead acid, nickel cadmium, nickel metal hydride, lithium ion, lithium sulfur, and lithium air. Supercapacitors. Because of the high power density and long life, electrochemical and supercapacitors, ES for short, or ultra capacitors have high demand. Chen, 2013, Jia, 2015. The primary purpose of a supercapacitor in the hybrid electric vehicle is to boost the battery or the fuel cell for providing the necessary power for acceleration. Charging scheme. Charging is more than just charging the battery. It also requires an advanced control system to regulate the current and voltage. The loading and unloading process helps to determine its safety, durability, and performance of a battery motor. These are some comparison of level for charging an EV by Dost, 2015. For the level 1, the voltage is 120 and current is 15. Level 2 is much higher than level 1 with much faster charging speed, whereas the level 3 is much more higher than level 1 to almost 100 kilowatt of power. Chapter 3, Methodology. Flowchart. This is a flowchart of the methodology. Start, we're gonna have the problem statement. After that, we're gonna review some literatures and submission of design ideas. After that, proposal of the prototype designs. Then design material selection and stress test through CAD, which is a computer aided device. Computer aided design. And after if you got the result, if you pass, you can go straight to a detailed design of the mini EV. If you fail, gonna return to the proposal of prototype design and make another design. Detailed design of the mini EV can show the future design of the vehicle, of the mini vehicle. Also, after that, you have purchased material for the fabrication process and some components. Lastly, the fabrication process of the mini EV. And ship design ideas. These are several ideas from around the world. You see over there, electric moped type. This is a mini ATV. This is a go-kart made from PVC pipes. We also got Citroen Ami, which is legal on the road. This is an off-road go-kart, which has a higher ride height. This is a 2-seater go-kart, and under that is a electric tuk-tuk, which can provide more space for more people. Prototype design testing. The design of go-kart chassis. This is the design of a go-kart chassis with some dimensions. Material selection. We selected IC 1018, which is a mild or low carbon steel. The reason is because it has good balance between strength, toughness, and ductility. Also, the price is not too high compared to the others. As you can see, the other three is the IC 1020, the IC 1026, and IC 4130. Even though the IC 4130 have a very high tensile strength yield, but the price is very high, so it makes it difficult to make this project. Results of the chassis analysis. As you can see from the chassis analysis using the ANIS CAD program, the impact from the front have the force of 7.652 kN. The total deformation is 0.2567 mm. Equals the equivalent strength is 32, and the factor of safety is 3, which is quite high. Whereas for the rear, with the force of 7.652 kN, the same. The total deformation is much lower at 0.179 mm. Equivalent stress is much lower at 38.957 megapascal, and the factor of safety is 5.663. And the impact from the side with the forces of 5.102 kN. Total deformation is 0.189 with the equivalent stress of 39 megapascal, and the factor of safety of 5.88. Higher the better. This is the result. On the top is the max total deformation. From the left is the front collision, front impact. The center is the rear impact, and the right side is the side impact, as you can see from the deformation. And for the bottom is the max principal stress. Front impact, rear impact, and side impact. Component purchasing. Some of the most affordable and good quality of component that could be found is at an online store, which is Shopee. It was selected for the purchase. Equipments. These are some of the equipments that would be used when fabricating the mini EV. An angle grinder, a power drill, and last but not least, an arc and TIG